Today we're going to look at some word problems for trigonometric functions. So it's going to focus on right triangle trigonometry and SOHCATOA. So we're going to start with this problem. An airplane is at an elevation of 35,000 feet. So this way up here. So here's our airplane. Okay. And it begins its approach to an airport. So our airport must be over here. Okay. And so this is that 35,000 feet. Okay. It begins its angle of descent is 6 degrees. So this 6 degrees piece right here, this is equivalent of an angle of depression. So that's referring to from our line of sight. So the line of sight, or how the plane had been headed, is right like that horizontal. Okay, but how it's actually going to head is start to descent down that way. Now, obviously, I am not drawing this to scale. Okay, this is significantly steeper than 6 degrees, but it's going to work for our picture anyway. So this angle of descent is outside our triangle. It is 6 degrees right there. Okay, and because I have two horizontal lines and this are parallel, that means I have alternate interior angles. So this 6 degrees, that's the outside the triangle for our angle of depression, is the same as this angle of elevation down here, 6 degrees also. Alternatively, I can also fill in this angle here. So if this angle of depression 6 degrees, and I know this whole piece has to be 90, that makes this piece here 84. So I can work with this with the 84 degrees that's up here, or I can work with the 6 degrees down here. So at this point, we want to know what is the distance between the airport, so that was right here, maybe it's JFK Airport, and a point on the ground directly below the airplane. So here's the point on the ground below the airplane, and we want to know this distance here. Okay. So I'm going to use, since I have opposite and adjacent, nothing on the hypotenuse, I want to use tangent for this particular problem. And again, I could model this with the 6 degrees, or I could model it with the 84 degrees. If I model it with the 84 degrees, I would have tangent of 84 is equal to x over 35,000. Okay, at that point, I'm going to have 35,000 times tangent of 84 is equals x on the other side because I'm running out of space. And then I'm going to get my calculator out. One thing to keep in mind when I use my calculator, I want to make sure that I am in degree mode. I don't have a calculator on this one anymore, so I can't show you the actual screen. Sorry about that. So when I type this into my calculator, I'm going to get x equals 333,002. Okay. So the next question says, what is the approximate air distance between the plane and the airport? That's asking for the hypotenuse. So instead, I'm still going to work off of that same picture, but instead I want this length here. I'm going to call it y now because I can't use x. I've already used x. And now I want to either use cosine or sine to find it. And so I want to use the 35,000 because I don't want to use this estimated one. I'm going to use y. Alternatively, I could also use the Pythagorean theorem with the two sides that I have there. But since the goal is to practice trig, I'm going to practice more trig. So I am going to use sine of 6 degrees using the other angle. So I'm working from this one's perspective this time. So this will be my opposite, and this would be my hypotenuse. So I chose sine. Sine of 6 is 35,000 over y. Now I'm going to cross multiply. So this is over 1. Sine y times sine of 6 is 35,000. Sine of 6 degrees is a number, so I can divide both sides by sine of 6. So I get y equals 35,000 divided by sine of 6. So the distance that the plane actually has to travel, because it's going down along that slanted length, it's going to travel further. So the actual distance that it has to travel is 334,837 feet. I rounded to the nearest whole foot on these, but if you wanted to go to the tenths or the hundredths, that'd be okay. So let's take a look at another one. So again, on this problem, on the first one I used tangent, first part I used tangent because I was looking for this distance down here along the bottom. Whereas in the second part, I was looking for the hypotenuse. I had to use a different trig ratio. I used sine instead. I could have also used cosine and done it with 84 degrees. So, a buoy in the ocean is observed from the top of a 40-meter high oil rig. The angle of depression from the top of the tower to the buoy is 6 degrees. How far is the buoy from the base of the oil rig? Pause the video right now and try this independently. All right, so now that you've had a chance to try it, I'm going to draw it. So I have an oil rig. Looks like that. That's wonderful. It's just like an oil rig, right? And then I have a buoy in the ocean. Maybe I should have made the ocean blue. Okay. So from the top of this, the horizontal be right there. Okay. And then we're going to measure an angle down from there. See this angle of depression that I'm creating? Again, similar to the last one, not that accurate in the picture, but we're not going to judge about that because pictures are not drawn to scale. So this angle of depression is 6 degrees. This is 40 meters tall. And then I want to know how far away is the buoy from the base of the oil rig. So this is the base, bottom of the oil rig, and I want to know this length here. Okay, I can fill in by all, because again, I have parallel lines. The water and this horizontal line of sight are parallel, which provides a 6-degree angle there because of these alternate interior angles. Okay, and then from here, we're going to decide which one we want to use. I have opposite and I have adjacent, so that's telling me tangent. So I'll have tangent of 6 degrees is 40 over x. I'm setting it up with the 6 degrees, but that's not to say that I couldn't have used 84 degrees as I start to write 84. Okay, I could have used that as another way of doing this problem. It's just the wonderful thing that we can approach this with different ways and different things depending on which I was more comfortable with. Am I more comfortable with by dividing by that tangent of 6 degrees? So here I get x is 380.6. I'm going to go to the tenths because it didn't say where to round to. Meters away. Here's one more. During a hot air balloon ride, Billy looks down at an angle of depression of 35 degrees and sees a sheep in the distance. If the sheep is 25 feet from the point directly below the balloon, how high above the ground is the balloon? Round your answer to the nearest tenth of a foot. Take a minute, pause the video, and try this one. All right, so here we have our hot air balloon. Okay, and we have a sheep. 1, 2, 3, 4. I don't know why I have everything purple this time. So our line of sight again is always horizontal because nobody's sitting in a hot air balloon looking down at their feet. And then the actual spot that he spots the sheep in the distance down that way. This time I might have actually gotten it pretty close to a 35-degree angle. So this is that 35 degrees. This time I'm going to do it without using ultimate interior angle. So if that 35 degrees is outside there, if I wanted the angle that's inside, I would do 90 minus 35, or 60, not 65, that's 110, it's 100, 55. Okay, the sheep is 125 feet from the point directly below the balloon. So here's the point directly below the balloon. There's our sheep. This distance is 125. How high above the ground is the balloon? X. Okay, so here I'm going to use tangent. Tangent of 55 degrees is equal to 125 over x. Again, alternatively, if I used this alternate interior angle, I'd have 35 there. Say tangent of 35 is x 120. Both of these two equations will give me the same answer. It just depends on what setup you are more comfortable with. So then I can multiply by x, or cross multiply, isolate x, and we get 87 point. If I solve the other one, the one I have in blue here, I get 125 tangent of 35 degrees equals x. Which also gives me the same answer. And it was feet. Feet. Hope this helps.